In section 5.5, we're going to learn some factoring shortcuts that are related to multiplication principles you may or may not have learned back in Algebra 1. In Algebra 1, the multiplication techniques here are not really very useful, so if your class skipped it, that would make a lot of sense. So we have to pretend that we're learning multiplication at first. But remember, factoring is just the reverse of multiplication. So if we learn a factoring rule, it's the same as learning a multiplication rule. So here are the two examples we want to work out. Notice the green one and the blue one, they're very similar to each other. The only difference is one of them has a minus sign in the large part and one of them has a minus sign in the smaller part. In order to multiply these out, we're going to do things the rudimentary basic way. We're just going to simply distribute. I'm going to take the A and distribute it through, and I'm going to take the B and distribute it through. When I multiply by the A, I get a to the third minus a to the second B plus ab to the second. And when I multiply by the B, I get a to the second B minus ab to the second plus b to the third. But also, don't forget, you have to collect like terms, and some really interesting things happen here when you collect like terms. This a squared b and this a squared b cancel each other out. And this ab squared and this ab squared cancel each other out. So when you're all done, you have a very simple answer, surprisingly simple answer. It's just a to the third plus b to the third. So that's kind of a magic trick for multiplication, but for factoring, that's actually pretty useful. Remember, factoring is to go the opposite direction. So what we've done here establishes a factoring rule. It says that if you have a cubed plus b cubed, that's the same as a plus b times a to the second minus ab plus b to the second. So doing this multiplication has taught us a factoring rule. The other one works very similar. We're going to distribute in the a. We're going to distribute in the negative b in this case. When we multiply everything there by a, we get a to the third plus a squared b plus ab squared. And when we multiply everything by negative b, we get negative a squared b, negative ab squared, negative b to the third. And like in the previous problem, some things cancel out. That cancels that, this cancels this, and all we have left is a to the third minus b to the third. Almost the same thing we had with the previous problem, just a minus sign instead of a plus sign. And therefore, we have created a factoring rule that looks like this. A to the third minus b to the third is the same as a minus b times a squared plus ab plus b squared. Notice that if you were to describe what these shortcuts are about in words, what you would say is that these are the sum and the difference of cubes. So this might be easy to mix up with the difference of squares shortcut we learned in section 5.4, but they're cubes instead of squares, so it is a different situation. Try to keep them straight. And when we were doing things in 5.4, those techniques were called shortcuts. But I got to change the name a little bit here because these aren't really shortcuts. There's no other cut. There is no long way that you can do the problem that's an alternative to this. So you really don't have a choice about using these. You don't have any other thing that you can use. These are necessary. If you don't learn them, these things are unfactorable to you. You have to use these shortcuts, so shortcut isn't really the proper name. So let's see a few different examples of what you actually have to do to use these shortcuts to do problems. So here's one. First of all, which one is it? Is it sum or difference? Well, that's easy. It's got a minus sign in the middle. It's a difference. Once you've identified that it's a difference problem, then you have to sort of translate it into a to the third minus b to the third. There has to be something to the third minus some other thing to the third. So this is like taking square roots, but you're taking cube roots. You're trying to figure out something to put here that when you cube it, you'll end up with 8x cubed. So that's 2x. 2 times 2 times 2 produces 8. X times x times x produces x cubed. And the 1, that's really simple. 1 to the third is the same as 1. So essentially what you're doing here is you're establishing that a is 2x and b is 1, and then you just plug into the formula. A minus b, a squared plus ab plus b squared. So that's going to be 2x minus 1, 2x squared plus 2x times 1 plus 1 squared. And if you can do those in your head, go right ahead and do them in your head. And they're not all that difficult to do. But when the numbers get larger and the terms have more variables and things get more complicated, you might want to actually write it out the way I'm writing it out here. But I bet a lot of you didn't need to write it that way. You could have written 4x squared right off the bat. 2x times 1, I bet you could do that in your head. And 1 squared, you could probably do that in your head. So if you were to skip right to this, that makes perfect sense. It's a perfectly reasonable thing to do. So there's one example. Not a particularly difficult example. The 1 makes that part really easy. Let's do one that's slightly more challenging, like this one here. So, is it a sum or a difference? Pretty clearly a sum. So the formula we're trying to make fit is the formula for a cubed plus b cubed. So we need to turn this into something cubed plus something cubed. So in this case, it's h cubed. That part's easy. And the 27, that's 3 times 3 times 3. That's 3 cubed. The formula here is a plus b times a squared minus ab plus b squared. And you'll notice that looks almost exactly like the other formula. It's just where the minus sign goes. So as a general rule, you'll notice that this first minus sign is the same, and this minus sign, or this sign here, is the opposite. So if you're doing a sum, this part will be plus. If you're doing a difference, that part will be minus. And then the second sign is plus or minus, reverse of whatever you had there. So plug in for a, the letter h. Plug in for b, the number 3. A plus b will be h plus 3. This will be h squared. This will be h times 3, but that's not the right way to write that. And this will be 3 squared, but that's not the right way to write that either. So make sure you clean things up and write them in proper mathematical notation. 3h, not h times 3, and 9, not 3 squared. I think we only need to do one more example. So, one more example here, slightly larger numbers. So is it a sum or a difference? This one's a difference, which means we're trying to fit the formula a to the third minus b to the third. So we want to have something to the third minus something to the third. So let's see, to get 8x cubed, you've got to have 2x times itself 3 times. And to get the 125, we have to have 5 cubed. And then we're going to plug in, instead of a, we're going to plug in 2x. Instead of b, we're going to plug in 5. And we're going to be plugging into the formula a minus b times a squared plus ab plus b squared. So a, we're plugging in 2x. B, that's 5. And here's a place where I really start to suggest it's a good idea to write out the a's and b's before you try multiplying or squaring things. There's just too much to keep track of, so much happening all at once that taking it one step at a time might be a lot easier. So here we would have 2x minus 5 times 4x squared plus 10x plus 25. One last little piece of advice I'd like to give you. If you're combining what you're learning here in 5.5 with the other factoring techniques you've learned, that second piece there, the 4x squared plus 10x plus 25, that's tempting. It looks like maybe you should do something with it. Maybe it factors. And you might find yourself wasting a lot of time trying to factor that out. And if you'd like to, go ahead and try. You'll learn a lot, but you're going to be learning by failing. It doesn't turn out to factor at all. So typically, this part is usually prime. If you forgot to pull out a common factor in the beginning or something like that, there are exceptions. Sometimes it's not prime, but usually it's a waste of time to try to factor it.